Hello, everyone. This is Melanie Maxwell, your guest speaker, I guess, for this week, and I will be talking about topic 20, probability. Let's start first by looking at our standards for sixth grade regarding probability. This is a significant topic for sixth grade. If you're looking just at CST, we're looking at 6 different items regarding probability. The first key standard relating to probability is representing possible outcomes for compound events in an organized way and expressing theoretical probability, which links directly to the standard 3.3 in statistics, data analysis, and probability as far as how we represent those probabilities as ratios, proportions, decimals, percents. So knowing your standards also, this should sound familiar with the fractions, decimals, percents, equivalencies. It also relates back to number sense 1.1, which is also 3 standards, but that's on a number line. So keep in mind as you go through this topic that you might want to represent those probabilities not only just numerically, but also on a number line to incorporate those skills together. Now we will go over to the actual topic. Again, if you look at the big idea, you'll hear the same language of we are representing or we're looking at an event and describing it numerically. And another one of the standards is making predictions. And that's where I should have noted that. That's standard 3.2 is actually predicting using the ratio. Pay attention to 3.4 and 3.5. This first word, understand the probability of disjoint events, understand independent and dependent. So when we go through and talk about a couple of those points, keep in mind that you need kids to not just compute, but understand and have that balance. Some key points to pay attention to here. As I already mentioned, this is a ratio. You've been working with ratios for months now with the sixth grade. It's another opportunity to bring that up to them. That's a ratio of the number of favorable outcomes to the number of all possible outcomes. And most of our work is done around finding all of the possible outcomes and then listening to the question about what are the favorable outcomes. And that's another point to keep in mind as you go through different things. If you start getting confused by what's going on, which happens in some of the lessons, keep clear in your mind that there are methods to find all the possible outcomes. From there, I need to pay attention to the question as far as which of those are the favorable, how are they organized? Do I need to put limitations on those outcomes based on the questions I'm being asked? As I mentioned before, this is your opportunity to review your fractions, decimals, and percents. And we'll touch more upon the mutually exclusive and disjoint events in just a second. When you are working with probability, the biggest emphasis is on finding outcomes at this point. And so trees, tables, organized lists are your ways to find the outcomes. And that will allow you to find all of the outcomes and then go back in and count which ones are the favorable outcomes. The counting principle is a way to numerically find how many outcomes there are, but it does not identify what those outcomes are. So keep in mind these work together. It shouldn't just be that kids are computing to find outcomes. They should be tying that computation back to their table. They should be tying it back to the tree. They should understand that this multiplication occurs because for each one of these outcomes, I have 2 possible outcomes that goes with it. So that's why I end up with 2 times 2, because for each group, there's 2 in it. And that'll be key throughout the whole thing. Whenever there's a computation method presented, then keep tying it back to the table or the tree and see if you can see within that and have kids explain using their table or tree why that computation method will work and when it applies. So just to summarize, our key points are that we are finding all possible outcomes. We're paying attention to the questions that are asked. Where we can, we're going to incorporate a number line and have kids express probabilities within fractions, decimals, and percents so that we get that extra bang for our buck in reviewing prior content. And pay attention to the difference between when you're looking for the number of possible outcomes and then exactly which outcomes you're looking for based on the question. Our final piece, which we're going to do an activity, which will be for lesson 26. Thank you. All right, here we are ready to do our activity. Lesson 26, the interactive learning. What I've done with this is just taken the interactive learning and the idea of the tiles in the bag, but added in an opportunity to review prior standards and again hit our heavy hitter standard of being able to represent probabilities and coming back to the ratio, decimal, percent. Key thing when you go through this activity is keep in mind that we're always asking, will I pick a blue tile? Throughout this entire thing, the theoretical probability is about picking a blue tile. So to begin, we're going to have 2 red tiles and 3 tiles that we're going to be placing into a bag. So we have our manipulative bag. So I need my 2 red tiles and my 3 blue tiles. For each one of these 5 experiments, I want to know what is the probability of picking a blue tile. So I'm going to first list my possible outcomes. If I were to put all of these in the bag and only draw 1 tile out at random, what could come out of the bag? I could pull out a blue, I could pull out the next blue, I could pull out the next blue, I could pull out a red, I could pull out a red. Because in this I'm not looking at compound events and the interaction of those events, I'm just going to use an organized list for this. The theoretical probability then is, okay, my ratio is possible outcomes, 1, 2, 3, 4, 5. And then again, I want to know about picking a blue tile, so I have 1, 2, 3 ways I can pick the blue tile. There's my ratio, and because it is a part to whole relationship, it is also a fraction. We're going to then, for me to convert it to a decimal, one way I do that is if it's in tenths, it's easy to convert. So there's my equivalent fraction, my equivalent decimal, and my equivalent percent. I have now expressed the probability of pulling a blue is 60% or 6/10. Now, I get to actually try this out today. So we're going to be predicting how many outcomes I would have, how many blue tiles I would pull in 15 trials. So I'm going to put my 15 trials here, and I'm trying to find my predicted probability. One of my, well, I need to go back to my ratio. Here's my probability. This one I can see equivalent ratios is probably going to be the quickest way to find it. So I would estimate that I would have around 9. Because this is theoretical probability, my experimental probability should be close to that. So let's find out. And I have my beautiful gift bag. However, you can use lunch sacks because I couldn't find my lunch sacks today. So trial 1. No, I did not get red. So I'm going to record I just want to record how many blue that I pull. But I don't want to lose track of how many I've done. So I'm going to put my blue up here and put my total tiles. So I've pulled once and I did not get blue. Notice I'm putting the tile back in the bag. It says just draw a tile. Now I do my next trial and oh, that didn't count because I pulled 2 at once. I pulled a blue. Blue, second trial, blue, third trial, and so on up to 15. This last column here, we're going to address after we have discussed these different events. So you have students go through and express the probability for listing it, theoretical, predicted, and then they can do the experimental. You can decide what order that you want them to do them in. And as an interactive, if you have them read the information, have them identify what they need to do, and work on it a little more towards have the Standard for Math Practice 1 of having them make sense out of the situation. Or you can use a little bit of this video and show them how that first row works. The key thing you need to make sure is on B, C, D, and E is we're doing 2 events, but I am only finding the probability for the second event. As you go through the lesson and look at the challenge activity asks about the probability of pulling that second tile as a blue one. And so that's when you get into the independent, dependent, and using computation and so forth. So this interactive is just to introduce the concept of independent, dependent, and these probabilities here are only for that second pull. So for example, on B, I draw a red tile and I replace it and I draw another tile. I am back up to it being like this first probability where I'm only drawing 1 tile. Because I put that red one back, it didn't matter whether it was red or blue, which is in line with D. These are both independent because whatever happens for the first one does not affect the second trial. However, C and E is where I draw the red tile out. It does not go back in. Now, I have pulled a red one out and not put it back in. Now my outcomes have changed. So do students see that I still have 3 blue tiles, but I only have one red one because I did not replace it. And so now I have a 3 out of 4. And then you can do your work with that. Same thing here, it affects it because I pull a blue tile, I do not put it back. I now have a 2 out of 4. Oops, 2 out of 4. Because I have 2 blues and 2 reds. So I have a 2 out of 4 probability of pulling a blue when I do that second draw. Students can then explain how can one event affect the probability of another event. This can be your discussion question, leading to kids identifying that when you put it back, it does not affect the second time. When you do not put it back, it does. That's the time you can come back and say, I have some vocabulary you can use. This really is, it's not a compound event, so there's no events intermingling with each other. This one would be an independent event and so forth, and I will show you the document that you have available below this video. It includes the completed form for you. Let's look at what that looks like in the lesson. Again, here we're just talking about the numeric, but let's tie the numeric back to a situation. Let's tie that computation back to this situation of, did I put the tile back or not? And one question that you can use repeatedly with independent, dependent, mutually exclusive, so forth, is does it matter? Does it matter that I put the tile back? Does it not matter? Did that affect the possible outcomes? Did that affect the probability of the event? So for the lesson, we want to look at the challenge activity because that's really the focus of the lesson, is what that probability is for the compound event. However, by laying this foundation, it helps us understand the independent and dependent events. So in looking at the challenge problem, our question is, what is the probability of drawing 2 blue tiles in a row? So for each time, we're looking at the probability of a blue and a blue tile being pulled. All right? And so we need to look at our possible outcomes. and then the outcomes in which there's a blue, and the number of those. For me, finding compound events, I could do a tree. However, the tree is going to be fairly large. So when there's multiple events or 5 different possibilities here, that's when I tend to go to a table. So I want to put my first draw here. So then I need to do my second draw. I need one for each of my tiles. So there's my blue, there's my next blue, there's my next blue, there's my red, there's my red. So there's all of my possible outcomes for the second draw. This goes back to what I was talking about earlier, that you need to look at all the outcomes and then let the question choose which of those outcomes you're going to be working with. Now, this is like tedious. Why don't I just multiply? Why don't I just multiply? That's what the lesson's about. However, it's the understanding piece. I can just multiply, but it's one more procedure that I'm adding to the many procedures in my head at this time as a 6th grader, where I should be building that procedure on a strong foundation of understanding. All right, so I want to look at, for A, I want to draw 2 blue tiles, so I'm looking for the 2 blue tiles, and in one I draw a tile, and we're going to go with that. I put it back, whatever it is, and then I draw another tile. Look at my probabilities. I can look at this and say there are 9 outcomes that are blue out of a total of 25 outcomes. If I want to look at that through a computation lens, I have, for the first draw, 3 out of 5 possibilities of pulling a blue. For the second draw, I again have 3 out of 5 possibilities to draw a blue. But if I'm to combine those, I end up with 9, the 3 times the 3, outcomes that are my desired outcomes, blue, but I have a total possibility of 25 outcomes. So we figured out A. Let's try B now. What is the probability that I am going to draw a red tile, put it back, draw another? However, we're trying to get 2 blue. So right there I can say I drew a red tile. I now have 0% probability of drawing 2 blue tiles, which is my desired outcome. I look at C in the same way, in that once I've pulled that red tile, I have 0 probability of getting 2 blue tiles in my draws. So let's look at D for what can happen. If I draw a blue tile, I had a 3 out of 5 probability of drawing that blue tile. Again, in the second draw, because I replaced it, I have a 3 out of 5 probability of drawing a blue tile. Does this look familiar? Back to here, when we're looking at the probability of pulling, that I would actually have pulled the blue tile the first time. Here I said I did, but that was the probability of it. Let's look at the final one. Again, 3 out of 5 chances to draw a blue tile on the first round. So let's say I did draw that blue tile. I can now look at that second event. I now only have the 2 out of 4 that I could pull. That is the probability to pull a blue tile, giving me 6 out of 20 possibilities. Because when I pulled that blue tile, right, I then knocked out the second round. Pulled this first blue tile out. That happened. Okay. However, I can't pull that same blue tile again. So I have lost that set of probability. So I now have 1, 2, 3, 4, 5, 6 out of 1, 2, 4 by 5. So I now have 6 out of 20 is the probability for pulling 2 blue tiles where I do not put the tile back in after I've pulled a blue tile. So hopefully that helps show you how you can work on the understanding of the computation using a table and then lead you into the lesson where it works predominantly on the computation and works. So for this first part here, you can again do the table. I encourage you to work it out yourself beforehand and try it out, because it takes that thinking and how does this affect the next event? How does the first event affect the second event? Then you can move into the different computation methods, because there's a conceptual foundation to come back to and think about, oh yeah, that took away that possibility. I hope this has been helpful in learning or revisiting lesson 26 if you've taught it before, and have a great week.